My girlfriend is cracked at Tetris.
So I decided to put my programming knowledge to good use and build her a custom Tetris clone that she can play from her phone or computer whenever she wants. You might recall from my last video that I was working on drone control software to control a drone through the internet with a nice web interface. Well, I have a little secret. The front end that I built with React, the entire thing I pretty much vibe coded. I thought I had a much better understanding of React and JavaScript than I really did, which led me to repeatedly force-feeding ChatGPT error messages. I didn't like how reliant I had become on ChatGPT for completing that project, and I also realized that I needed a better understanding of front-end technologies. So I decided that I would do the Odin project. If you haven't done it, I highly recommend it. I actually feel like CSS isn't just some unreadable runes now, and as a primarily back-end developer, that's saying a lot. So here it is, girlfriend Tetris. No frameworks, no ChatGPT, just straight grind coding. First off, I needed to design the UI. I wanted to run this by my girlfriend before committing to 5 hours of agony. Once that was completed, it was actually time to start building the static UI. Getting it to be responsive on mobile was difficult, and I finally just settled on just using media queries below a certain screen width. Although I still feel like there's a better way of doing this, I'm sure there's some obscure combination of CSS properties that would make this work without media queries. Now that that was completed, I moved on to the game logic. I represented the board as a 2D array of numbers and all the pieces as smaller 2D arrays that I copied onto the board at will. I won't go into all of the logic that was needed for the game, but I will explain two of the functions, the gravity and rotation logic, because I actually really like how this part turned out. The gravity function, exert gravity on board, looks simple on the surface. It just pulls the active piece down one row. But under the hood, it's doing something kind of smart. It first creates a hypothetical version of the piece, one row lower, and checks whether that move is valid before committing to anything. This avoids a bug where you accidentally overwrite part of the board while moving a piece that isn't supposed to be moved. The valid gravity move function is where the magic happens. It checks that the new coordinates are still inside the board and aren't colliding with existing blocks. But instead of naively checking every square, it only cares about the parts of the piece that are actually moving into new territory, which it figures out by converting the piece into a string, and then seeing whether the spot below is part of the current piece or not. If it's not, and it's occupied on the board, that's a no-go. Simple, fast, and it works. Is it elegant? Kind of. Is it cursed? A little. But it gets the job done. Now the rotation logic, this is probably my favorite part of the whole codebase. If you've ever tried to rotate a group of coordinates in place, you know it's one of those things that sounds easy until you realize that LeetCode classifies it as a medium problem. I don't know about you, LeetCode mediums are pretty hard for me. So instead of doing whatever the heck this fancy algorithm is, I just sidestepped the pain entirely by building a little bounding matrix around the current piece. From there, I used a classic trick, transpose the matrix, then reverse each row. Boom, 90-degree rotation. 2 lines of code, and suddenly I'm a mathematician. This is the kind of move that makes you feel like you understand linear algebra, even though you once cried over a Khan Academy matrix video. Then I reconstruct the rotated piece, check if it's actually legal, i.e. not colliding or flying off the board, and then commit the change if it's good. If it's not, we pretend like it never happened. Kind of like that time I tried to understand promises by nesting .then calls inside of each other and accidentally built a callback Jenga tower. I should probably make a mention here of how I intended to architecture this game. First off, I wanted to experiment with using a completely serverless architecture. The whole application starts first with you, the client. The client makes a request from the browser to girlfriendtetris.com. This request then gets routed to an API gateway on AWS. The API gateway has 2 types of routes. Routes that serve static files and routes that do some processing via Lambda. In order to get the game core files, one needs to visit the root of the application, which serves the HTML, CSS, and JavaScript from an S3 bucket. Now in terms of the Lambda functions, I have 4 of them, all written in Python. We have a start game Lambda, which generates a UUID to identify the client's game. This is shipped to the client on game start, so the client can use this code to post their high score. If the client does not have one of these codes, they will not be able to post a high score. Next, we have the getScores Lambda, which retrieves all the scores, which is a maximum of 100 from the DynamoDB database where they're scored. In order to get the scores, we also need a way to post them. The post Lambda takes care of posting the user's current score to the database. It requires the log of score updates made by the client, as well as the game code that was created by the start Lambda. Now you may have noticed, but the game runs entirely on the client, and this isn't by accident. You're probably screaming at your screen right now.
Idiot boy.
Idiot boy.
Idiot boy.
But this was an intentional trade-off. I could have designed the game so that all the logic was verified by the lambdas, making it more tamper-proof. However, this would have likely required a lambda call for every operation performed by the user. Piece rotations, slamming, moving left or right, etc. These get to be expensive when doing lots of tiny operations. The second reason why I opted for this option is execution speed. Lambdas have what are known as cold start times, which happens if you don't use the lambda often enough. This increases latency in a game where lots of operations need to take place within 100 milliseconds. Most likely, I would need to perform some additional optimizations to ensure I could even get a relatively short response time, i.e. less than 250 milliseconds. So ultimately, this was the way less secure option, but more convenient and cost-effective one. And considering I'm not making any money from this project, I didn't want to burn a hole in my pocket in case Tetris Master 42069 decides to play 10 hours of Tetris a day on my site. I've implemented some basic score integrity checks to mediate spoofing, although a sufficiently motivated person could probably do it. That said,
I'm watching you, Wazowski. Always watching.
Anyway, that brings us to our final lambda, the delete game lambda. This basically just deletes a game code without using it to post a high score so that my database doesn't get flooded with unused codes when people decide to never finish a game or play a game that results in a score too low to end up on the high scoreboard. Now we are almost done, but because I hate myself and I don't want to be a ClickOps dev, there's one more thing I need to do. In the past, ClickOps is exactly how I provision my resources. I went through the AWS Management Console and manually configured all the resources I needed. In professional development environment though, that's not how things work, and I figured, hey, I'm graduating in a year. I should probably understand what professional development looks like. So I introduced to you the Cloud Development Kit. This is an SDK put out by AWS that allows you to programmatically configure any AWS resource. That way you can avoid being a dummy and accidentally delete your API gateway that you spent so long configuring. To be completely fair, I probably would have done the same thing and didn't even know that you could deploy cloud infrastructure this way until reading this post. Since I was using the CDK from the start, I figured I'd wire up the entire infrastructure like a real engineer. An S3 bucket for the front end, DynamoDB tables for scores, 4 lambdas for all the game logic, an API gateway to glue everything together, and a custom domain with TLS. Felt good, felt clean, until I hit my first CDK moment. I copied a code snippet straight from AWS docs, literally from their own site, and instantly got hit with a type error telling me I passed a dict where it wanted a block public access object. Love that, so now I'm debugging a problem caused by AWS, not even following their own API, except I didn't know that at the time. So I spent many painstaking hours digging through the docs, rewriting code, debugging errors, and trying to figure out why a method that was clearly documented was telling me it didn't exist. Yes, I'll be opening a PR on the CDK repo. But after all that, I finally have this to present to you. With this code, I can spin up the whole stack whenever I want. I just rerun the cert generation to get my domain validated, then redeploy the app infrastructure. S3, DynamoDB, Lambda, API gateway, all in one go. And with the little addition of a manifest.json file, my application works on mobile almost as if it were a native app. at least if you have an iPhone. I don't own an Android, so I never bothered to test it there. My girlfriend owns an iPhone, fight me. So with all that said, I think that pretty much wraps this one up. If you want to check it out, link is in the description. See you guys next time.